Hello everyone, so my name is Dushyant Kumar and I will be discussing today the very important concept in chemistry known as covalency and excitation theory. Guys, इसके बिना इस concept के बिना chemistry totally अधूरी है क्योंकि this is a very important concept to understand the whole nitty-gritties of the concepts which are there in our chemistry. So first of all, we should know that what is covalency. And guys, covalency is the maximum number of covalent bonds that an atom can form using its empty orbitals. अब ये simple definition से चाहे ना समझ आए, so for that I'll take the help of two examples to explain this whole phenomena. First of all, I'll take the example of carbon, and by considering its ground state configuration, we know that its ground state configuration is 2s2 2p2, and on arranging these these electrons into their respective orbitals, we will come to know that it has two unpaired electrons. That is, we can say that it can form two covalent bonds in its ground state. So we can easily say that it is bivalent in nature. But we know that carbon is not bivalent in nature. Carbon is tetravalent in nature. So accordingly, we will write its excited state configuration. And on writing its excited state configuration, which is 2s1, 2px1, 2py1, 2pz1. And again, on arranging these electrons into their respective orbitals, we will come to know that it has four unpaired electrons now. So we can easily say that it will form four covalent bonds in its excited state. That is, it is tetravalent in nature. So another example to explain this whole phenomena I'll take is of phosphorus. And similarly, I'll take its ground state configuration, which is 3s2, 3p3, 3d0. And on arranging these electrons into their orbitals, it has three unpaired electrons in its ground state. That is, it will form three covalent bonds in its ground state, which will prove its trivalent nature. And on writing its excited state configuration, it will have five unpaired electrons in its excited state. That is, we can say that it will form five covalent bonds in its excited state. So by this we can say that carbon is tetravalent in nature and phosphorus has covalency equal to 3 or 5. That is, it is trivalent or pentavalent in nature. But the question here is the very important question, this is the doubt of many students among us, that why did not we write carbon covalency as 2 or 4? Like we wrote for phosphorus as 3 or 5. To understand this question, we need to understand the whole excitation theory. So its reason is excitation theory. Now guys, we will understand the major concept, the excitation theory. If we understand this concept, we will never face any difficulty, in understanding the whole concepts of inorganic chemistry, organic chemistry. So let's begin with the excitation theory. Excitation is of two types. The first one is free excitation. Free excitation, the example of free excitation is of carbon. In carbon, the energy gap between the low-lying 2s orbital and high-energy 2p orbital is very low. Is very low for excitation via thermal energy via surroundings. That is, इसकी जो डेल्टा एनर्जी जो गैप है 2s एंड 2p ऑर्बिटल में वो इतना कम है कि वो इलेक्ट्रॉन ऑटोमेटिकली एक्साइट हो जाता है थर्मल एनर्जी जो कि सराउंडिंग से मिलती है. इट्स डेल्टा इज वेरी वेरी लेस देन द थर्मल एनर्जी. सो as it no longer stays in bivalent state, because the electron will automatically promote to the higher energy level. It no need any external energy. It will just excite by the thermal energy by the surroundings. So we can say that it no longer stays in its bivalent state. Therefore, we have to consider the covalency of carbon as 4, not 2. Now, another example to understand the excitation is a forced excitation. This is another type of excitation. And the example of forced excitation is of phosphorus. This one is forced excitation. Now here, the energy gap between the low-lying 3s orbital and the high-energy 3d orbital is very high. Is very high to excite just via thermal energy. Here delta E, the energy gap between the low energy 3s and 3d orbital is very very high than the thermal energy from the surroundings. Therefore, we can say that the electrons will not automatically excites to the 3d orbital, like it was happening in the case of phosphorus. Therefore, we can say that these excitations are conditional in nature, also known as endergonic process. Endergonic process means the external energy is required for the excitation. That is why in case of phosphorus, before excitation its covalency is 3, and after excitation, which is purely conditional in nature, its covalency become 5. Therefore, we write covalency of phosphorus as 3 or 5. So guys, मैं ये उम्मीद करूंगा कि ये कॉन्सेप्ट फुली अंडरस्टैंड हुआ है, क्योंकि अभी कार्बन और फास्फोरस की सिंपल सी एनालॉजी है जो हमें नॉर्मली समझ नहीं आती. बट आई थिंक आई होप आई हैड एक्सप्लेन द होल कॉन्सेप्ट विद इन फ्यू मिनट्स. आई विल समराइज द होल कॉन्सेप्ट विद इन हाफ अ मिनट. In carbon, the process was not endergonic because the electrons automatically excite हो रहा था from low energy level to higher energy level. ठीक है, इसको एक्सटर्नल एनर्जी की जरूरत नहीं पड़ती. बट इन द फास्फोरस जो डेल्टा ई गैप है बिटवीन द लो एनर्जी ऑर्बिटल एंड हाई एनर्जी ऑर्बिटल, वो इतना हाई है कि उसको थर्मल एनर्जी भी दी जाए तब भी इलेक्ट्रॉन एक्साइट नहीं करेगा into the higher energy orbital. Therefore, the external energy is required for the excitation. Therefore, these processes are known as endergonic processes. और एक्साइट जब नहीं है तो इसकी कोवेलेंसी देखिए 3 अनपेड इलेक्ट्रॉन्स हैं, तो इसकी जो कोवेलेंसी वो 3 होगी. बट एज सून एज द 3s electron will excite into the 3d orbital, then we will have 5 unpaired electrons, which will result into its pentavalent state. Thank you very much, guys. So this was a very short video from my side. If you find my channel, my video as informative, so kindly do subscribe my channel, like my video, and also share this video and channel to your friends, to your cousins who are studying chemistry in the lower classes, who are preparing for any entrance exams, because this channel is very helpful for them also. I will come with very informative videos in my upcoming series. So kindly do subscribe, share my channel. Thank you very much.